Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I believe all of you are doing great, all of you are having the good time. So my dear students, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly let me know in the chats. Quickly let me know in the chats with some fire emojis. If all of you can hear me, if I'm perfectly audible, visible to everyone. Yes? Quick in the chats. So my dear students, we are done with the marathons. There is only one marathon which is pending in class 11th physics part 2, which I've already conveyed to Yavar sir. He'll be taking it soon. Okay, you need not to worry. Perfect. Well, in the today's session, I'm going to discuss the PYQs of the chapter, of chemistry basically, right? And the duration of this particular session may be 3 hours, 4 hours, 5 hours, whatever, I do not know, right? We'll be trying to solve all the PYQs which have been asked in your chemistry, and let me give you the idea of how many slides do we have. We have got 422 slides which we are going to do in the today's session. And my dear students, why I came up with this particular session, let me give you the quick context of that as well. So first of all, when it comes to the NEET 2024 paper, trust me, not less than 20 questions, not less than 20 questions will be directly or indirectly asked from the PYQs. You would have seen it earlier as well, right? I'm giving you the assurance, if you watch this particular session completely, my dear students, more than 20 questions directly or indirectly will be from this particular session, because every year when it comes to the NEET examination or even JEE examination, let me tell you, 20% of the paper, minimum 20% of the paper is directly, indirectly from the PYQs. Yeah? So are you all ready for that? Are you all ready for this particular session? I would want every one of you to call up everyone, right? This particular session is for all the NEET 2024 aspirants. Call up everyone. And I can see not everyone has liked the session yet. I would want you guys to smash that like and mark your attendance right now. Yeah, I know I'm live after like 3-4 days because there was some family emergency, as I conveyed you already in the Telegram. Yeah, perfect. So already duration of this session will be 3-4 hours, not more than that. Not more than that. Already, people, I would want every one of you to smash that fire emoji in the chat so that I'll get to know how excited you guys are for this particular session, right? That's the way I keep starting all my sessions, you know it. I would want the chats to be flooded with the fire emojis. Everyone, people. I would want the chats to be flooded with the fire emojis. I missed you guys too. Let's make this week very effective, guys, right? Let's try to cover a lot of things, right, with a lot of sessions which we have planned for all of you. So I would want you guys to be active on this channel for the upcoming 7 days, because these 7 days, trust me, they are going to change your lives for sure. Yeah? Perfect. Perfect. There will be separate sessions for biology. I have already conveyed Ambika ma'am. She'll be taking some very important sessions when it comes to biology as well. You need not to worry. So guys, are you ready with your pen and paper? Are you all ready with your pen and paper? Quickly in the chats. Are you all ready with your pen and paper? Are you all ready with your pen and paper? Say yes or no in the chats quick. There is a session coming on Monday. On Monday, we are taking a session in which we shall be discussing 1000 questions of PCB, right? That is going to be the marathon of 8 to 10 hours. And that session will approximately start at 4 p.m. Perfect. So my dear students, in that particular session, we are going to discuss 1000 very important questions with all of you, right? Not just from chemistry. It's going to be biology followed by chemistry followed by physics. So be ready for that and expect 90 plus questions directly or indirectly from that particular session as well. Yeah. A lot of students would have watched it last year as well. Before NEET 2023 examination, we came up with that particular session in which we discussed some top 1000 questions of PCB, and a lot of questions directly and indirectly were asked from that particular session, right? So that particular session is coming for you as well. That is going to happen day after tomorrow. That means on coming Monday, right? So be ready for that as well. Be ready for that as well. Yeah? Just give me a second. Just give me a second. Perfect. So let's get going. Let's get started without wasting a lot of time. Let's get going after so long, right? I'm going to solve the questions with you. So let's start with the first chapter. That is something which I love the most, epic mole concept. Let's try to solve all the PYQs which have been asked from this chapter first, right? All the PYQs which have been asked from the chapter mole concept. Okay, so let's start the session with the PYQs of the chapter mole concept. I hope you all are ready with your pen and paper, because I would want you guys to give a try to every single question which I have come up with in this particular session. And please call up everyone whosoever is preparing for NEET 2024, because this particular session is definitely, for sure, going to be beneficial for everyone, my dear students. Because trust me, 20 questions directly, indirectly are asked from your PYQs. Yeah? Okay, so let's get going. Let's get started with the first question, which is on your screen. Look at the question carefully. I believe all of you would have seen this particular question, right? The question was asked in your NEET 2020. Which of the following has maximum number of atoms? How do we, my dear students, how do we solve this sort of a question? Which of the following has maximum number of atoms? Let's look at the options. The first option is 1 gram of magnesium. We are given with 1 gram of magnesium. So first of all, what I'll be doing, I'll be calculating the number of moles of magnesium. Number of moles of magnesium will be given mass of magnesium in grams divided by molar mass of magnesium, right? Now, since I calculate the moles, I'll be multiplying these moles with the Avogadro's number. I'll be getting the number of atoms in atoms over here. So atoms of magnesium will be moles multiplied by Avogadro's number. So it's Na divided by 24. So first option seen. Look at the second option, 1 gram of O2. 1 gram of O2. Calculate the number of moles of O2. It is given mass of O2 divided by molar mass of O2, right? Given mass of O2 divided by molar mass of O2. Now, my dear students, if I ask you how many molecules of O2 we have, how many molecules of O2 we have, I'll be multiplying the moles with the Avogadro's number. So it's Na divided by 32. Now, my dear students, how do we calculate atoms? You know already, in one molecule of O2, we have got 2 atoms. In one molecule of O2, we have got 2 atoms. So in these many molecules of O2, we'll be having 2 multiplied by these many atoms. So it's going to be 2 multiplied by Na by 32. So it's going to be Na divided by 16 atoms in total. So these are the atoms which are present in the second option. Look at the third option, 1 gram of lithium. 1 gram of lithium. Calculate the moles of lithium first of all. Moles of lithium is equal to given mass of lithium divided by molar mass of lithium. You know it. Now calculate the atoms of lithium directly. Atoms of lithium will be moles multiplied by Avogadro's number. So it's Na divided by 7. So these are the atoms. Look at the last one, 1 gram of silver. So it's going to be number of moles of silver will be equal to given mass of silver divided by what? Divided by molar mass of silver. If I multiply this term with Avogadro's number, I'll be getting the atoms, and atoms here is going to be moles multiplied by Avogadro's number. What was I supposed to calculate? Look at the options. Which of the following has maximum number of atoms? Look at all these values. Na by 24, Na by 16, Na by 7, Na by 108. So which one is the maximum value among all these values? This is the maximum value. So option C is the one which is going to be the correct answer of this particular question, right? And I believe all the students have already mentioned option C over here, right? Moving on to the next question. Moving on to the next question. Look at this particular question, people, quickly. A mixture of gases. A mixture of gases contains H2 and O2 in the ratio of 1:4 weight by weight. So what does this statement mean? This statement means that mass of H2 divided by mass of O2. Mass of H2 divided by mass of O2 is nothing but 1/4. This is given to me. What is the molar ratio of these two gases? What is the molar ratio? What is the ratio of their moles? What is the ratio of their moles? So we are supposed to calculate this ratio. Number of moles of H2 divided by number of moles of O2. And how do we do it? Pretty much simple. Number of moles of O2 means number of moles of H2 means mass of H2 divided by what? Divided by molar mass of H2. Number of moles of O2 means mass of O2 divided by molar mass of O2. That comes up over here like this. Now, as per the question, this term it is given to us already, WH2 by WO2. That's given to us as 1/4. Now, my dear students, what is the molar mass of O2? You should know it, 32 grams. What is the molar mass of H2? That is 2 over here, right? So this is 2, 1, this is 2, 16, this is 4, 1, this is 4, 4. So the final answer of this particular question is going to be 4:1. Is it clear to everyone? The final answer of this particular question is going to be what? It is going to be 4:1. So 4:1 is the correct answer of this particular question, which was asked in your NEET 2015. Yes, done and dusted. Let's move on to one more question. We have to be very quick. We need to be very quick, my dear students. We need to be very quick. Look at this particular question. The question was again asked in your 2015, NEET 2015. The number of water molecules is maximum in. Where do you see the maximum water molecules? First of all, in the first option, we are already given with 18 water molecules. In the second option, we are given with 1.8 grams of water. So first of all, I'll be calculating the number of moles of water, which is equal to given mass of water divided by molar mass of water. The value comes out to be 1/10, right? So these are the moles. Now, if I multiply these moles by the Avogadro's number, what do I get over here? I will be getting the molecules of water, which is moles multiplied by Avogadro's number. So it is Na by 10, Na divided by 10, right? So these are the molecules. Look at the next one, 18 grams of water. 18 grams is the molar mass of water. That means 18 grams is the mass of 1 mole of water. 18 grams is the mass of 1 mole of water. And you know, 1 mole of water contains how many molecules? Na molecules. Na molecules of water, right? The last one says 18 moles of water. So I'm already given with the moles. If I multiply this with Avogadro's number, I'll be getting the molecules. So how many molecules do we have over here? It's going to be 18 Na molecules. 18 Na molecules of water. Now, my dear students, which of the following has maximum water molecules? Over here, 18 water molecules. Na by 10 water molecules. Na water molecules. 18 Na water molecules. So it's absolutely going to be option 4, which is going to be the correct answer of this particular question. Right? I believe everybody solved this question properly. Moving on to one more question. Moving on to one more question. The question was asked in your NEET 2014. The question was asked in your NEET 2014. When 22.4 liters of H2, when 22.4 liters of H2 gas is mixed with Cl2 gas, each at STP, the moles of HCl formed will be, right? The moles of HCl formed will be. So as per the question, we have to calculate the moles of HCl over here. Now, how do we exactly solve this? My dear students, initially at time t is equal to 0. If I ask you how many moles of H2 do we have? Given volume divided by 22.4, the value comes out to be 1. So we are starting with 1 mole H2. How many moles of Cl2 do we have? Given volume divided by 22.4, the value comes out to be 0.5. And initially this is going to be 0. Now, my dear students, try to understand carefully. Whenever you are given with the amounts of all the reactants, which concept do we use? We use the concept of limiting reagent. And in the limiting reagent concept, you know, we are supposed to balance the reaction first. And the reaction is already balanced. Now it's high time to check which of the reactant is your limiting reagent. Now, how do we check that? Given moles divided by Avogadro's number. Given moles divided by Avogadro's number. The one which gets the least value, that's always the limiting reagent. So 1 by 1 is 1. 0.5 by 1 is 0.5. So this is my limiting reagent. If this is my limiting reagent, this is going to decide the entire product formation, right? the Cl2 is going to decide the entire product formation. Now, since Cl2 is the limiting reagent, so it would have got completely consumed in the reaction, right? Now, my dear students, as per stoichiometry, 1 mole of limiting reagent is giving us 2 moles of HCl. Therefore, 0.5 moles of limiting reagent will give us 2 multiplied by 0.5. That comes out to be 1 mole of HCl. So, at the end of the reaction, 1 mole of HCl is getting formed. So, with the help of simple limiting reagent concept, you can solve this sort of equation. And I believe all the students have already given the correct answer. Wonderful. Wonderful. Perfect. Perfect. Moving on to one more. This is a very basic question. I believe you would have solved this question many a times. The question was asked in your 2010 examination. Quickly. The number of atoms in 0.1 moles of triatomic gas. So, for example, we are given with the triatomic gas. This is my gas. How many moles of this gas are we given with? We are given with 0.1 moles of this gas, right? If I multiply this term with the Avogadro's number, can I get the molecules of A3? Absolutely, I'm going to get the molecules of this triatomic gas. It is going to be 0.1 Na. So these many molecules we have. Now, am I supposed to calculate molecules or atoms? I need to calculate atoms. Now, my dear students, you know, in one molecule of A3, how many atoms do we have? We have got 3 atoms. In one molecule of A3, we have got 3 atoms. In 0.1 Na molecules, how many atoms do we have? 3 multiplied by 0.1 Na. The value exactly comes out to be 0.3 Na atoms. Right? Now you can put the value of Na over here and get the desired answer. I believe this is clear. I can see a lot of students are coming up with option 2, and absolutely it's option 2 which is the correct answer of the question. Moving ahead to one more question. Be very quick. Look at this particular question. People. The weight of one molecule of compound, the compound that's given to us, that is C60H22. We are supposed to calculate the weight of one molecule of this, and the weight has to be calculated in grams. My dear students, if I want to calculate the molecular mass of this compound, I can do that. Molecular mass of the compound that's given to me will be equal to atomic mass of carbon is 12 multiplied by 60, right? Plus hydrogen, it's 1 AMU multiplied by 22. This value comes out to be 720 plus, is this value coming out to be 720? Check it out. 12 multiplied by 60, right? Okay, this is 122 here. This is not 22, this is 122. So this comes out to be 720 and this comes out to be 122. The value comes out to be 842. 842U. This is the molecular mass of the compound. 842U. This is the molecular mass of the compound, right? Someone is saying, sir, I was not born in 1995. By the way, I was born in 1995. Yeah? I was born in 1995. Okay? Perfect. All right. This is the mass of one molecule. But this is the mass in U, right? Am I supposed to calculate the mass in U? No. I'm supposed to calculate the mass in grams. How do I do it? 842U I can break as 842 multiplied by 1U, and you must be knowing 1U, 1 AMU, that is nothing but 1.66 into 10 raised power minus 24 grams. You need to do a bit of calculation and you're done, you're sorted. Yeah? Perfectly done? Perfectly done, people. So after solving, you'll be getting this as your final answer. Do remember 1 AMU or 1U, that is nothing but 1.66 into 10 raised power minus 24 grams. If you would have seen my marathons for the mole concept, my dear students, you would be easily solving this question. Yeah? But you don't seem to be 29. I know that, unfortunately. I can do nothing about that. Yeah? Let's talk about my age afterwards. This is the high time to crack the PYQs. Yeah? Okay. One more question. 5 years before I was born. Boron has 2 stable isotopes. Right? One is your B10 and one is your B11. Perfect. As per the question, we are given with their percentage abundances as well. The percentage abundance of the first isotope is 19%. Second one is 81%, right? And my dear students, you must be knowing by now. Whenever the element exists in the form of isotopes, we calculate its average atomic mass. Average atomic mass formula is nothing but M1A plus M2B divided by what? Divided by A plus B. Let me tell you, this is the value of your A, this is the value of your B, this is the value of your M1, this is the value of your M2, right? So put all the values over here. I'll be getting the M average, which is equal to M1. M1 is 10, A is 19, plus M2 is 11, B is 81, divided by A plus B is how much? 100. When you solve this term, the value comes out to be 10.81 AMU. So this is the average atomic mass of boron, which I was supposed to calculate, right? Simple. Simple, people. I believe it's done. Yeah. Moving on to one more question. Look at this particular question. One more question, people. If Na is Avogadro's number, then the number of valence electrons in 4.2 grams of N3 negative. So first of all, if I ask you how many moles of N3 negative we have, it is equal to mass of N3 negative divided by molar mass of N3 negative. The value comes out to be 0.3. So these many moles of N3 negative we have. Perfect. Now people, if I ask you how many ions, how many N3 negative ions do we have? It is going to be equal to moles multiplied by Avogadro's number. So these many ions of N3 negative we have. Now people, if I ask you in one N-tri negative ion, how many valence electrons do we have? First of all, in N-tri negative, in one N-tri negative, there are in total 10 electrons, out of which 2 will be going into the first shell, 8 will be going into the second shell. So these are what I'll be calling as valence electrons here, right? Simple. So one N-tri negative ion, it contains 8 valence electrons. Therefore, as per the question, 0.3 Na N-tri negative ions will be containing 8 multiplied by 0.3 Na valence electrons. The value exactly comes out to be 2.4 Na valence electrons. Is there any option like this? Absolutely. It's the first one, which all the students have already, right, posted in the chats. I believe it's again clear. Quick. Quick, people. Yes, done. Perfect, guys. Let's move on to one more question. Okay, this question was asked when I wrote JEE Mains. Right? This question was asked in that year, right? It's not 1979, it's 2014. What do you think? Quick, people, kill it. And trust me, I'll tell you something. When I saw this question, I did not solve this question when I was writing my JEE exam. I already knew the answer. It was 7:32. I still remember it. Okay? I remembered this question. I had already solved it. Perfect? Before the examination itself, I had solved this question. I remembered its answer and I did not solve it when I saw this particular question in the examination. Yeah? Perfect? So the question is the ratio of the masses, the ratio of the masses of O2 and N2. The ratio of the masses of O2 and N2 is given to us as 1:4. The ratio of their molecules, right? Whatever will be the ratio of the moles, same is going to be the ratio of the molecules. Yeah? So moles of O2 divided by moles of N2 will be equal. Moles of O2 means mass of O2 divided by molar mass of O2. Moles of N2 means mass of N2 divided by molar mass of N2. Correct? This term is already given to us, this particular term. It's given to us as 1:4 multiplied by molar mass of N2 is nothing but 28 divided by molar mass of O2 is nothing but 32. So 4147. So the final answer is nothing but 7:32. So 7:32 is the answer of this particular question. Done and dusted. Right? Moving ahead, people. Moving ahead. Very quick. Look at this particular question. The question was asked in 2000. Right? The question was asked in 2000. Kill it. My dear students, as per the question, we have got two elements X and Y. They are combining to form two compounds. The first compound is XY2. The second compound is X3Y2. Two compounds have been formed. As per the question is concerned, 0.1 mole XY2. Its mass is 10 grams. As per the question, 0.05 moles of X3Y2. Its mass is 9 grams. Correct? Now, think carefully. 0.1 moles of this compound weighs 10 grams Therefore, 1 mole of XY2 weighs how much? 10 divided by 0.1. The value comes out to be 100 grams. Correct? Similarly, I'll say 1 mole of this particular compound, its mass will be 9 divided by 0.05. The value will be 180 grams. Perfect. So, my dear students, if you look carefully, this is the mass of 1 mole of this compound. This is the mass of 1 mole of this compound. So, should I be calling this 100 grams as the molar mass of XY2? Yes. Should I be calling this 180 grams as the molar mass of X3Y2? Yes. So, if I ask you, what is the molecular mass of XY2? What is the molecular mass of XY2? You will say it's 100U. It's 100U. Instead of grams, you'll write U. If I ask you similarly, what is the molecular mass of X3Y2? The molecular mass of X3Y2 will be 180U. Perfect. Now, people, what is molecular mass? Sum of atomic masses. Let's assume that atomic mass of X is A. So the equation becomes A plus 2 times B. Here comes out to be 100. And over here, it's going to be 3 times A plus 2 times B. It's equal to 180. Just subtract these two equations. This minus 2B cancel. 3A minus A comes out to be 2A. 180 minus 100 comes out to be 80. So A over here comes out to be 40 AMU. What was A? A was the atomic mass of X. A was the atomic mass of X, right? A was the atomic mass of X. So A was the atomic mass of X. So the answer has to be what? It has to be C. Done? Done, people? So can you solve this sort of equation as well? Quick. Be very quick in the chats. Be very quick in the chats, people. Yeah? Perfect. Moving on. Let's not stop. Let's not stop at all. Moving on. Look at this question. Look at this question, guys. Equal masses of H2. Equal masses of H2. We have got H2, we have got O2, and we have got methane. Equal masses of H2. Let's say we have got W grams of this, we have got W grams of this, we have got W grams of this. As per the question, we are given with equal masses of H2. Equal masses of all these have been taken in a container of volume V at temperature 27 degrees centigrade at identical conditions, the ratio of their volumes. We have to calculate the ratio of their volumes. So whatever is going to be the ratio of their moles, same is going to be the ratio of their volumes, right? Whatever is going to be the ratio of their moles, same is going to be the ratio of their volumes. So if I want to calculate the ratio of their moles, it's going to be given mass of H2 divided by molar mass of H2, given mass of O2 divided by molar mass of O2, given mass of CH4 divided by molar mass of CH4. So this is the ratio of the moles. So W cancel. The value here is 1 by 2. The value here is 1 by 32. The value here is 1 by 16. Now, my dear students, if you take the LCM of denominators, the LCM comes out to be 32, right? LCM comes out to be 32. I'm multiplying every term with that LCM. So I believe the value here comes out to be 16. The value here comes out to be 1. The value here comes out to be 2. So 16 is to 1 is to 2 is going to be the final answer of this particular question, right? Whatever is the ratio of the mole, same is going to be the ratio of their volume. Perfect, people? Done and dusted again? Done and dusted again? Done and dusted again? One more question, which was asked in 2019 from the same chapter. The number of moles of hydrogen molecules required to produce 20 moles of ammonia. So, for the formation of ammonia, this has to be the reaction. N2 gas plus 3 times H2 gas, it gives 2 times NH3 gas. This is my reaction. People. Right? This is my reaction. Now, as per the question, how many moles of NH3 are being formed? As per the question, 20 moles of NH3 are being formed. And as per the question, for the formation of 20 moles of NH3, how many moles of hydrogen are required? That's something I'm supposed to calculate. Isn't it simple again? Can I say 2 moles of NH3? As per stoichiometry, 2 moles of NH3 are formed from 3 moles of H2. Therefore, 1 mole of NH3 is formed from 3 divided by 2 moles of H2. Therefore, as per the question, 20 moles of NH3 is formed from 3 by 2 multiplied by 20. The value comes out to be 30 moles of H2. So, as per the question, I got to know 30 moles of H2 are required to produce 20 moles of NH3. So, the answer is option C, done and dusted. Right, people? I believe you would have solved this sort of a question earlier as well. Is that quick? Quick, people, quick. Tell me the answer of this question. I believe you would have solved this question many a times too. Tell me the answer of this particular question. Quickly, everybody. Everybody in the chats. Everybody in the chats, quick. I want you guys to be very quick. Very quick, people. I have solved this question many a times with you only in the marathons, etc., etc. As per the question, we have to do the combustion of C3H8, propane, right? When you do the combustion of any hydrocarbon, it leads to the formation of carbon dioxide and water. You know it. Now, just balance the reaction. Just balance the reaction. This is 3. This has to be 3. This is 8. This has to be 4. And this has to be 5. The reaction is balanced. Now, since the reaction is balanced, from the stoichiometric coefficients of the reactants, I am getting to know that 1 liter of propane, exactly requires 5 liters of O2 for its complete combustion. 1 liter of propane exactly requires 5 liters of oxygen for its complete combustion. So that's something which I was supposed to calculate. How many liters of O2 are required for the complete combustion of 1 liter of propane? So what is the answer? 5 liters of O2 are required, right, for the complete combustion of 1 liter of propane. Correct? Correct, people? Done and dusted again. Done and dusted again. Done and dusted. Look at this particular question. The question was asked in 2009. The question was asked in 2009. Look at this. 10 grams of hydrogen. 10 grams of hydrogen, right? And 64 grams of oxygen were filled in a steel vessel and exploded. Amount of water produced in this reaction. Amount of water produced in this particular reaction will be. That is the question. Correct? That's the question. So first of all, if I ask you, how many moles of hydrogen do we have? Given mass of hydrogen divided by molar mass of hydrogen. So 10 by 2 is 5. How many moles of O2 do we have? Given mass of O2 divided by molar mass 32. So the value comes out to be 2. So initially we are starting with these many moles of reactants. Correct? Now again, this is the question based on limiting reagent. So people, identify the limiting reagent. Identify the limiting reagent. Identify the limiting reagent. Is the reaction balanced? The reaction is not balanced yet. First of all, the reaction has to be balanced. Now it's balanced. Right? Now, 5 by 2 is 2.5. 2 by 1 is 2. This value is coming out to be lesser, so this is limiting reagent. It is done. 1 mole of O2 gives 2 moles of water. Therefore, 2 moles of O2 gives 4 moles of water. So I got to know that 4 moles of water have been formed. So 4 moles of water have been formed. Done and dusted, right? Perfect. Solved completely. Yes, we have solved it completely. Okay, look at this particular question. The question is, how many moles of magnesium phosphate will contain 0.25 moles of oxygen atoms? That's the question. Now people, look at this particular magnesium phosphate. If you look at magnesium phosphate, if I take 1 mole of magnesium phosphate, can you let me know in 1 mole of magnesium phosphate, how many moles of O do we have? We have got 4 2s are 8. We have got 8 moles of O. We have got 8 moles of O, right? Right, people? If I reverse the reaction, 8 moles of O, 8 moles of O are present in 1 mole magnesium phosphate. Right? 1 mole magnesium phosphate. Correct? Right, people? 8 moles of O are present in 1 mole of magnesium phosphate. Therefore, 1 mole of O will be present in 1 divided by 8 moles of magnesium phosphate. Correct? As per the question is concerned, 0.25 moles of O. 0.25 moles of O will be present in 1 by 8 multiplied by 0.25. This is moles of magnesium phosphate. So this comes out to be 1 by 8. This is 1 by 4 here. So the final value is 1 by 32 moles of magnesium phosphate. So as per the question, 0.25 moles of O will be present in 1 by 32 moles of magnesium phosphate. That's something which I was supposed to calculate, right? Right, people? Done and dusted with this question. When you solve this, the final answer of this particular question will come out to be how much? The final answer will be 3.125 into 10 raised to minus 2. Right? Perfect, people? Perfect, people? I believe I'm clear. Moving on to one more question. Quick. Tell me the answer of this question quickly. Tell me the answer of this question quickly. It's again very simple. I believe you would have solved this question many a times. As per the question, we are starting with 0.5 moles of BaCl2. This is 0.2 moles of Na3PO4. This will be 0. This will be 0. Again, the question based on limiting reagent. What do we need to do? Given moles, divide by stoichiometry coefficient. 0.5 divided by 3. 0.5 divided by 3. And 0.2 divided by 2. Which one is coming out to be lesser? This is coming out to be lesser. So this is my limiting reagent. Right? This is my limiting reagent. Perfect. Now, how many moles of barium phosphate will be formed? Use the stoichiometry, people, here. 2 moles of limiting reagent gives 1 mole of barium phosphate. So 1 mole gives 1 by 2. 0.2 gives 1 by 2 multiplied by 0.2. The value comes out to be 0.1 mole of barium phosphate will be formed. Right? Option 4 is the correct one. Just the limiting reagent concept, nothing else. Just the limiting reagent concept, nothing else in this question as well. Yeah? Right, people? Let me know once the chat's quick. This session is for NEET 2024 aspirants. Okay? This session is for NEET 2024 aspirants. All right. Let's have a few more questions. Okay. I believe you can kill this question in lesser time. What do you think is the answer of this question? Quick, people. The molarity of HNO3 in a sample which has got the density this, mass percentage this. Do you remember? If you remember, my dear students, I've given you one result. Molarity is equal to 10 multiplied by density of solution in grams per ml multiplied by weight percentage of solute divided by molar mass of solute. This is one result which directly you can remember from now onwards to calculate molarity of the solution. Now, all the parameters are given to us. 10 multiplied by. What is the density of the solution? It's 1.4. What is the weight by weight percentage of solute? That is 63. What is the molar mass of solute? What is the molar mass of solute? That is 63. So 63 cancel. The value exactly comes out to be 14. So 14 is the molarity of the solution. Done and dusted. Right? Done and dusted, people. Quick. Similar sort of question was asked in 2009. Similar sort of question was asked in 2009. Solve the question, people, with a similar approach. I'm not solving this. You are solving this. Solve the question with a similar approach. Solve the question with a similar approach. Solve the question with a similar approach. Molarity is equal to 10 multiplied by density of solution multiplied by weight percentage of solute divided by molar mass of solute. Yeah? Correct? I'm not solving this question because you will have to use the same formula which I used like a few minutes back in the last question. Yeah? So after solving, it is option C which you'll be getting the answer. All right. JEE 19 question. See how basic the question is. The molarity of the solution obtained by mixing this. You're mixing two HCl solutions. We need to calculate the molarity of resulting solution. Don't you know molarity of mixing of non-reacting? It's M1V1 plus M2V2 divided by V1 plus V2. Correct? Now, people, it is just a matter of calculation, nothing else. What is M1? M1 is 0.5. What is V1? V1 is 750. What is M2? What is M2? That is 2 molar. What is V2? That is 250 divided by V1 plus V2. V1 plus V2. That comes out to be 1000. Correct? Again, a matter of calculation and you are done. You can easily calculate the molarity of the final solution. Yeah? These sort of questions are also asked. Perfect. Now, people, let's move on to the redox reactions. Did you get the idea of what kind of questions have been asked lately from the mole concept chapter? Did you get the idea, people? Quick, everyone. Quickly. Done? Done? Perfect. By the way, tomorrow, me and HSP sir at 11 a.m. in the morning, we are going to take a session. I hope you have seen the thumbnail as well, right? That session is already public. That is going to be most predicted paper of your chemistry for NEET 2024, in which we shall be exactly solving 50 questions, 50 most expected questions of chemistry with you. Me and HSP set together. Okay? So tomorrow exactly at 11 a.m. I would want every one of you to be there. Right? I would want every one of you to be there. Okay. NEET 2020. NEET 2020. What is the change in the oxidation number of carbon? What is the change in the oxidation number of carbon in the following reaction? CH4 plus 4 times Cl2. It gives CCl4 plus 4 times HCl. This is the reaction. This is the reaction. What is the change in the oxidation state of carbon, people? The oxidation state of carbon here will be -4. The oxidation state of carbon here is +4, right? So from -4 to +4, it's changing. Done. Basic question. Basic question. Oxidation state of chromium in CrO6, NEET 2019. CrO6 structure you should know. CrO6 structure you should know. Well, this is the structure of your CrO6. You should know it. Now, people, how do we calculate the oxidation state of chromium here? Look at this particular bond between chromium and oxygen. Oxygen is more electronegative, so it will have -1, this will have +1. Oxygen is more electronegative, -1 +1. Again, -1 +1. Again, -1 +1. Again, -1 +1. Again, -1 +1. If you look at the total charge on chromium here, it comes out to be 1, 2, 3, 4, 5, 6. So +6 is the oxidation state of chromium in case of your CrO6. Just remember the structure, right? Just remember the structure. All right, look at this question. Which of the following molecule cannot, okay, which of the following molecule can act as oxidizing as well as reducing agent? Which of the following molecule can act as oxidizing as well as reducing agent? My dear students, if you remember your H2O2, if you remember your H2O2, right? H2O2. H2O2 is a compound which shows dual nature. Sometimes it gets converted into O2, and in some other reaction, it gets converted into water, right? So this is the one, this is the one, this is the one which shows dual nature. In some reaction, it will act as the oxidizing agent. In some reaction, it will act like the reducing agent, right? Same goes for FeSO4. FeSO4, in some reaction, it gets converted into Fe tripositive. In some reaction, it gets converted into Fe. Again, it also shows the dual nature. FeSO4 also shows the dual nature. It sometimes acts as the oxidizing agent, sometimes acts as the reducing agent, right? Sometimes acts as a reducing agent. So answer of this question is H2O2. Simple question. Okay. AIPMT 1988, 1995, AIMS 1997. In three times the same question have been asked. The oxidation number of chromium in potassium dichromate. I believe you will kill this. You'll be remembering this, right? Right, people? Start with potassium. Potassium shows +1 oxidation state. There are 2 potassium atoms. Let the oxidation state of chromium be X, so it's going to be 2 times X. Let the oxidation state of oxygen is -2. There are 7 oxygen atoms. Net charge is 0. When you solve this, the value of X comes out to be +6. So +6 is the final answer. Done and dusted. Done and dusted, right? Perfect. JEE 2019. JEE 2019, the compound that cannot act both as oxidizing and reducing agent. The compound that cannot act both as oxidizing and reducing agent. My dear students, if you look at H3PO4, the oxidation state of phosphorus is +5 here. The oxidation state of phosphorus is +5. So I believe this phosphorus is already present at its maximum oxidation state. This +5 is already the maximum oxidation state of phosphorus. If +5 is the maximum oxidation state of phosphorus, that means this phosphorus cannot increase its oxidation state furthermore. It cannot increase its oxidation state furthermore. If it cannot increase its oxidation state, it cannot undergo oxidation. It cannot undergo oxidation. And the one which cannot undergo oxidation, that cannot be called as a reducing agent. So your H3PO4, it won't act as the reducing agent. Yeah? Perfect. Done and dusted. Moving on. Moving on. AIPMT 2009. You can kill this question. First you have PO4 trinegative. Then you have got SO4 dinegative. And that of chromium in Cr2O7 dinegative. You have to calculate the oxidation state of the underlined elements over here. And people, kill it and let me know the answer quick. Let me know the answer quick. Yeah? Quick in the chats. Quick in the chats. Phosphorus here will be in +5 oxidation state, sulfur will be in +6 oxidation state, and this also +6. So +5, +6, +6. Is there any option like that? Yes, option D. Option D. Option D. Look at this particular question. What do you think about this one? What do you think about this one? What do you think about this one? Highest oxidation state of manganese. Highest oxidation state of manganese. Manganese shows the maximum oxidation state of +7. You should know it. +7. And in which of the following it shows +7? It's going to be here, KMnO4. In KMnO4, manganese shows highest oxidation state, that's +7. Right? Perfect. So, and this is MnO4 dinegative. Here the manganese shows +6, and accordingly you can check. So maximum oxidation state of manganese is in KMnO4, where it is +7. Where it is +7. Tell me the answer of this question. AFMC. AFMC people. In the conversion, Br2 to BrO3 negative. Br2 to BrO3 negative. The oxidation number of Br negative changes from. Here the oxidation state of bromine is 0. Here the oxidation state of bromine is +5. So it's 0 to +5. Done and dusted, right? 0 to +5. No need to think a lot. No need to think a lot, people. No need to think a lot. No need to think a lot. Look at this one. In which of the following reactions are disproportionation reactions? Which of the following reactions are disproportionation reactions? Right? So first of all, if you look at the options, first of all, this is 2, 2, 2, and 2. Right? So that means 2 is already. I'm not going to check second. I'm not going to check 1. It's already disproportionation. Check first one. The first one is 2 times copper positive. It gives copper di positive plus copper. People, if you look carefully, the oxidation state of copper here is +1. Here it is +2. Here it is 0. +1 to +2 means increase in the oxidation state. +1 to 0 means decrease in the oxidation state. Right? So the oxidation state of same element is increasing as well as decreasing simultaneously. So I would say the Cu positive is undergoing disproportionation. Right? Absolutely. 1 is undergoing. Perfect. 1 is undergoing. So it can be either option A or it can be option B. Perfect. I just have to check the third one. I just have to check the third one. I just have to check the third one. Check it out. My dear students, manganese over here has +7 oxidation state, right? Over here it is +6. Over here it's +4. So +7 to +6, +7 to +6 decrease. +7 to +4 again decrease, right? So this cannot. So it's only 1 and 2. It's only 1 and 2. Kill it. Done and dusted? Done and dusted, people? Right? Look at this particular question. Substance that are oxidized and reduced. Substances, those are oxidized as well as reduced. Look at this question. The question has been asked in AIMS 2016. You should kill this one as well. People, if you look at H2O2, just look at H2O2. Just look at H2O2. Oxidation state of oxygen here is -1. Here the oxidation state of oxygen is -2. So -1 to -2. Decrease in the oxidation state. Decrease in the oxidation state is something which we call as reduction. So I would say H2O2 is undergoing reduction. And if H2O2 undergoes reduction, that tells you N2H4 will be undergoing oxidation, right? Substances which are oxidized and reduced. N2H4 is being oxidized, H2O2 is being reduced. N2H4 is being oxidized, H2O2 is being reduced. So it's option 2, which has to be the correct answer of this particular question. Yeah? Done? Done, people? All right, JEE 2019. JEE 2019. Example of the disproportionation reaction. Where do you see? Which of the following species is undergoing disproportionation? Can you check it out quickly? Can you check it out quickly, people? Everyone. Everyone in the chats. Can you check it out quickly? Everyone in the chats. Everyone in the chats. Kill it. Someone is saying, sir, basic padao. Basic ka time abhi gaya. This is the session for NEET 2024. Yeah? I would want answers in the chats, first of all. I would want answers in the chats. For basics, you can consult the marathons which we have taken. Tell me the answer quickly, guys. Everyone. 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 Absolutely. Copper here is in +1 oxidation state, right? Copper here is in +2 oxidation state. Copper here is in 0 oxidation state. So +1 to +2, increase. +1 to 0, decrease. Increase, decrease. What is happening? Disproportionation of CuBr is happening. So it's absolutely option D. It's absolutely option D. You all are perfectly right. You all are perfectly right. What is the oxidation number of sulfur in Na2S4O6? Na2S4O6. My dear students, do you remember its structure? This is S4. And this is O6. Na2S4O6. Na2S4O6. Now, calculate the oxidation state of each sulfur. This sulfur here will be in +5 oxidation state. This is 0. This is 0. This is +5. So if I ask you to calculate the average oxidation state of sulfur, it is going to be +5, +0, +0, +5 divided by, there are 4 sulfur atoms. So it's going to be +10 divided by 4. The value is nothing but +5/2. So +5/2 is going to be the average oxidation state of sulfur in Na2S4O6. Yeah? नहीं कुंदन मुझे पढ़ाना नहीं आता. Okay, you can go to some other channel. Perfect. I believe it's done. Understood? Moving on to one more question. The question has been asked in AIPMT 1994. Can you check it out? Can you check it out, people? Which substance serves as the reducing agent? Which substance serves as the reducing agent? Quick, quick, quick. Everyone. Everyone. Everyone, quickly. Which substance behaves as the reducing agent? Guys, you should kill this question. This is not something which I should be solving, right? This is not something which I should be solving. This is not something which I should be solving, yeah? Perfectly done. So if you look at this particular question, chromium here is in +6 oxidation state. Chromium here is in +3 oxidation state. +6 to +3, decrease. Decrease in the oxidation state means reduction. So Cr2O7 is undergoing reduction. Cr2O7 is undergoing reduction. If this is undergoing reduction, the one which undergoes reduction, that's called as oxidizing agent. So this is oxidizing agent. Automatically, this nickel becomes your reducing agent. And this H positive just tells you that the reaction is taking place in the acidic medium. Perfect. So I was supposed to check the reducing agent. So it's nickel, which is the reducing agent among all. Right? So it's nickel, which is going to be the reducing agent among all. Done, understood again. Moving on. Look at this question. Look at this question, guys. Kill it. Again. The oxide which cannot act as the reducing agent. The oxide which cannot act as the reducing agent. Which cannot act as the reducing agent. Guys, these are speed solutions going. Speed solutions. Speed solutions. You have to be very quick. I'm not going to wait for long. Quickly. Exactly. Wonderful. So if you look at carbon dioxide, my dear students, if you look at carbon dioxide, this carbon is at its maximum oxidation state. The carbon right here is present at its maximum oxidation state. If carbon is already in its maximum oxidation state, so it cannot further increase its oxidation state. It cannot further increase its oxidation state. And if it cannot further increase its oxidation state, I would say it won't undergo oxidation. It won't undergo oxidation. And the one which does not undergo oxidation, that cannot behave as a reducing agent. So carbon dioxide is the one over here which is not going to behave like the reducing agent. I believe this is again clear to everyone. Okay. One basic question. KBrO4. What is the oxidation numbers of bromine? Ames 2014. My God. Quick. Quick, guys. Don't think a lot. Do not think a lot. Do not think a lot. It's an easy question. It's an easy kill question. It's an easy kill question. I believe majority is coming up with option B. You all are perfectly right. It's KBrO4, right? It's KBrO4. Potassium will show +1 oxidation state. Let the oxidation state of bromine be X. Oxygen will show -2. There are 4 oxygen atoms. Net charge is 0. The value of X comes out to be +7. Done? And dusted. Moving ahead. Moving ahead, people. Okay, this is one more JE question. This question was asked long back in JE mains. Or maybe at that time it used to be AIEEE, as far as I remember. What is the oxidation state of phosphorus? Here. This is Ba, H2, PO2, hold twice. We have to calculate the oxidation state of phosphorus. Can we do it? Can we do it? First of all, I want you guys to do it. I want first of all you guys to do this question. Because maybe you might do a mistake. You might do a mistake in this. I want you guys to solve this first. I want you guys to solve this first. I want you guys to solve this question first. Last day strategies will also come. First, try to attend this session with 100% honesty, because this is going to be super beneficial for all the students who will be writing the NEET 2024. See guys, barium is from group second, and your group second elements, your alkaline earth metals, they show +2 oxidation state. So barium is going to show +2, right? Hydrogen will show +1. Hydrogen will show +1. How many hydrogen atoms do you have? 4 hydrogen atoms. Let the oxidation state of phosphorus is X, which makes it 2X. Let the oxidation state of oxygen is -2, and there are 2 oxygen atoms. Net charge is 0. Now it's just a matter of calculation, nothing else, right? So this is -4, and this 4 gets cancelled out. So 2X is equal to 2X will come out to be -2. So X value will be -1. Is it -1 or +1? I think I did some calculation mistake. Is that? I think I did some. Did I do any calculation mistake here? Or is this the answer? It has to be +1, right? So there is some calculation mistake which I've done over here. You can check it afterwards. Barium will show +2 oxygen state. Hydrogen will show +1 oxidation state, right? And there are 4 hydrogen atoms. Phosphorus is X, which makes it 2X. Oxygen will show -2. Okay, this is 4. These are 4 oxygen atoms, right? This is 4. Here was the calculation mistake. So finally, the value of X after solving will come out to be +1. Done and dusted. Moving on, people. Moving on to one more question. This is the question which has been asked in many examinations. Same question. NEET 2018, AIEEE 2013, JEE Mains 2021. Same question has been asked. The correct coefficients of the reactants. The correct coefficients of the reactants. Guys, I need to turn the lights off, okay? I need to turn the lights off. Okay. Now have a look. First thing, the reaction that's given to us, that is like this. MnO4 negative plus what? Plus oxalate ion. C2O4 di negative. It gives what? It gives your Mn di positive. And with that, you'll be writing carbon dioxide. So this is the reaction basically. This is the reaction basically. Now look carefully. Look carefully. Oxidation state of manganese here is +5. Here it is +2. So +5 to +2, what is the change in the oxidation state? That is 5. So I would say its N factor is 5. Oxidation state of carbon here is +3. +3 to +4. +3 to +4 change is 1. Change in the oxidation state. +3 to +4, that's 1. 1 is the change for 1 atom, but I have 2. So its N factor is 2. So first of all, I got the N factors of the reactants. My dear students, once you get the N factors, you need to crisscross these N factors. This 2 has to be the coefficient here. This 2 has to be the coefficient here. This 5 has to be the coefficient here. Okay? This 5 has to be the coefficient here. Now, this is 2. Make it 2. 5 2s are 10. So 10 carbon atoms. Perfect. Right? Now, people, we are supposed to balance the reaction in the acidic medium. In the acidic medium, what do? We balance oxygen first. So 4 2s are 8. 5 4s are 20. 28 oxygen on left side. 10 2s are 20. 20 oxygen on right side. So I would say right side is oxygen deficient. And how many oxygen deficiencies? 8 oxygen deficiencies. So I'll be adding 8 water molecules on this side. Now your oxygen is balanced. After balancing oxygen, try to balance hydrogen. There are 8 2s are 16 hydrogens on right side. So it has to be 16 H positives on left side. Now, my dear students, you are in a position to select your answer. You are in a position to select your answer. Quick. Quick, people. Everyone. Done? Done? Perfect, guys. Let me move on. Let me move on. Can you tell me the answer of this question? Tell me the answer of this question quickly, people. The formula mass of more salt is 392. The iron present in it is oxidized by KMnO4 in acidic medium. The equivalent mass of more salt will be. In your more salt, iron is present in Fe dye positive state. In your more salt, iron is present in Fe dye positive state. And you know, KMnO4 in acidic medium converts Fe dye positive into Fe tripositive. Right? KMnO4 converts Fe dye positive into Fe tripositive. In which medium? Acidic medium. You should know it. Now, calculate the change in oxidation state. Plus 3 to plus 4, change is 1. So I would say n factor of more salt, I would take as 1. If n factor of more salt is 1, equivalent mass of more salt will be equal to molar mass of more salt, right, divided by n factor. So this is going to be the final answer, 392 grams. Done and dusted. Right? Done and dusted. Done and dusted. One basic question. One basic question, people. One basic question. Tell me the answer of this particular question. In the process of oxidation, what happens in oxidation? In oxidation, oxidation number increases. Right? Right, guys? Tell me the answer. Oxidation involves the loss of electrons, right? So what will happen to electrons? Oxidation involves loss of electrons. So what will happen to electrons? Increasing or decreasing? Absolutely. Number of electrons decreases. So ready for atomic structure? Ready for atomic structure PYQs? Are you all ready for atomic structure PYQs? Quick. You would love these PYQs, I know that, because this is the chapter which nobody misses. This is the chapter which nobody misses. Are you ready for it? Perfect. Tell me the answer of this question. NEET 2020. NEET 2020. I'm given with one element, right? What do you have to calculate? Protons, neutrons, electrons. LU, atomic number 71. Mass number 175. So, how many electrons will be there? 71 electrons. How many protons will be there? 71 protons. How many neutrons will be there? Mass number minus atomic number. So, 175 minus 71 comes out to be 104. Right? So, electrons, protons, and neutrons. Electrons, protons, and neutrons. Yeah? Done and dusted. Do you remember this question? The question was asked in NEET 2021. One simple question. One simple question, people. What are we supposed to calculate? Wavelength of the electromagnetic radiation. You know, frequency is equal to C divided by lambda. So lambda has to be equal to C divided by frequency. C divided by frequency. This you already know. This is given to us. It's just a matter of calculation and you can solve it. Right? Just a matter of calculation and you can solve it. It's again an easy question, but maybe calculation wise you might get stuck here. So be careful with that. Be careful with that, people. Look at this question. AIMS 2019. AIMS 2019. A bulb is emitting electromagnetic radiation of wavelength how much? A bulb is emitting the electromagnetic radiation of wavelength this nanometer. The total energy of the radiation. The total energy of the radiation is 3 into 10 raised power minus 18 joules. The number of emitted photons will be. The number of emitted photons will be. Right? The number of emitted photons will be. You know, your E is equal to N times Hc divided by lambda. Right? Energy is given to me in joules, which is 3 into 10 raised power minus 8 is equal to N. I need to calculate. N I need to calculate. The value of H is nothing but 6.6 into 10 raised power minus 34. The value of C is nothing but 3 into 10 raised power 8 meter per second divided by lambda. Lambda will be 660 into 10 raised power minus 9 meters. I've taken every parameter as per SI system. Again, matter of calculation and get the value of n. That's all. And when you solve it, the value of n will exactly come out to be 10. Right? Perfect, people? Yeah? Right? Okay. One more question that has been asked in AIMS 2016. Energy and radius. Do you remember the formula? Energy of the electron in the nth Bohr state, right? It is equal to how much? Minus 13.6 Z square divided by n square, electron volts. You should know it. You should know it. Radius of the electron in the nth Bohr's orbit is equal to R naught n square divided by Z. Perfect. Angstroms. You should know it as well. Perfect. Now, energy and n square, they are inversely related. Energy and n square, they are inversely related. Perfect. Radius and n square, they are directly related. They are directly related, so it has to be option B. Again, one simple question. Again, one simple and basic question. NEET 2022. NEET 2022. If the radius of second Bohr's orbit of He positive, second Bohr's orbit of He positive is this, what is the radius of third Bohr's orbit of Li di positive? If the radius of second Bohr's orbit, right, of He positive, what is the atomic number of helium? It is 2. Radius of second Bohr's orbit is how much? It is given to me as 105.8 picometers. Perfect. What is the radius of third Bohr's orbit? What is the radius of third Bohr's orbit? Atomic number of lithium is 3. R2 value, we need to calculate. My dear students, you already know radius of the nth Bohr's orbit is equal to R naught n square divided by Z, right? So I'll say R1 divided by R2 is equal to N1 square divided by N2 square. This is Z2, this is Z1. Correct? I believe the question is done and dusted. Yeah? I believe the question is done and dusted. R1 value is nothing but 105.8. R2 we have to calculate. N1 ka square, 2 ka square is 4. N2 ka square, 3 ka square is 9. Z2 is 3. And your Z1, that is 2. Do you see this is one equation which carries just one unknown, so you can easily get the value of R2, which we were supposed to calculate. Right? Right, people? Again, done and dusted. And when you solve this, this is the answer which you'll be getting at the end. Okay? NEET 2019. What do you think? What do you think? What do you think about this particular question? Everyone. 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 This question has been asked many a times, guys. Right? Let me tell you the answer of this question. You have got Lyman series. You have got Balmer series. Lyman, Balmer, Paschen, bracket, fund. Correct? So here I'm writing U, V, I, and I. So this is ultraviolet. This is visible. This is infrared, right? This is also infrared, but you can call it as far infra. This is also far infrared. Now, what is the answer of this particular question? What is the answer of this particular question? Done? Is it visible? Visible, Balmer. Visible, Balmer. Anything can be asked from this particular one. Anything can be asked from this particular one. Okay, moving on to one more. Moving on to one more. Just a second. Look at this particular question. I hope you can solve this. I believe you can solve this. Identify the incorrect statement. Identify the incorrect statement. I have already identified, now you identify it. I have already identified, now it is your time to identify it. Now it's your time to identify it. Quick. Quick, people. Everyone. Yes, there'll be inorganic PYQs as well. Just wait for some time. Yes? It's absolutely going to be option D, right? It is telling you that dx square minus y square and dz square, are they similar to each other? Are they similar to each other? Do you remember your dx square minus y square? This is how your dx square minus y square looks like. Do you remember how your dz square looks like? Do you remember how dz square looks like? You should know it. You should know it, people. You should know it. You should know it. I believe you would be already knowing this. I believe you would be already knowing this. This is how dz square looks like. Are they similar? No, they are not. Yeah? No, they are not. Okay. One more question. It's again the asked question. A certain orbital has no angular node. No angular node means L value is 0. Right? Angular node is equal to L. L value is 0. L is 0 for which orbital? It is 0 for S orbital. Okay? 2 radial nodes. How do we calculate radial nodes? N minus L minus 1. This gives me radial nodes. It is equal to 2. So N minus 0 minus 1 is equal to 2. So N is equal to 2 plus 1, 3. So N is equal to 3, right? So the overall, your orbital is your 3s. Overall, the orbital is your 3s. Done? If you do not know, remember total number of nodes is given by the result n minus 1. Angular nodes we calculate with the help of azimuthal contour number. Your radial nodes or spherical nodes, how do you do it? N minus L minus 1. This is the formula. Correct? One more question was asked in your NEET 2019. Similar sort of question, which is just formula based. Orbital having 3 angular nodes. 3 angular nodes. Quick. Angular nodes. Angular nodes. That means L value is how much? L value is 3. Angular nodes is equal to the value of L. L is 3. Perfect. 3 total nodes. 3 total nodes. 3 total nodes. Total nodes are given by the formula n minus 1. So n is equal to 4. N is equal to 4. L is 3 for F orbital. So it's basically 4F. Done and dusted. Yeah? Done and dusted. Moving on to one more. NEET 2019. NEET 2019. Arrange the following on the basis of the decreasing order of their energies. Decreasing order of their energies. Use the n plus L rule. We have got 5F orbital. N value is 5. For F, L is 3. So 5 plus 3 comes out to be 8. Number 1. 6P. N value is equal to 6. For P, L is 1. So 6 plus 1 comes out to be 7. Then we have got 5P. So N value is 5. L value is 1. So 5 plus 1 comes out to be 6. 4D. N value is 4. L value is 2. 4 plus 2 is 6. Now, which one has got the maximum N plus L value? It's 5F. So 5F will have maximum energy, followed by 6P. Now, among these two, N plus L is same. Now, decide on the basis of N. Wherever the N value is more energy. So 5P comes after this, then comes your 4D. So this is the decreasing order of energy which I was supposed to calculate. Right, people? Done and dusted again. This question has been asked 2 times in the AIMS examination. 2 times in AIMS. Check it out. Check it out, my dear students. Check it out. Check it out. Quick. Check it out quickly. First of all, let me tell you, L is from 0 to n minus 1. You should know it. 0 to n minus 1. Your M, it is from minus L to plus L. Perfect. If you look at the first option itself, right? Okay, wait. And which of the following arrangement is possible? Okay, they are saying which of the following arrangement is possible. Is possible, right? Is possible. Look at the first option. N is 5. L is from 0 to 5 minus 1, 0 to 4. So 0, 1, 2, 3, 4. Anything is possible. So correct. M is from minus L to plus L. So minus 2 to plus 2. That means minus 2, minus 1, 0, plus 1, plus 2 is possible. Correct. Spin can be either plus 1 by 2, minus 1 by 2. So this is correct. I got the first one correct itself. Yeah. So read the question carefully. He is saying which of the following arrangement is possible. Right. I know a lot of students read it as which of the following is not possible. Because most of the times when a question is asked, from this, they ask you which of the following is not possible. But over here, they have given which of the following is possible. Right? So be careful with these sort of questions. Okay. Are you ready to start chemical equilibrium? Tell me, equilibrium or bonding, which one the next? Equilibrium or bonding, which one the next? Which one do you want the next? Equilibrium or bonding? Quick. Equilibrium or bonding? Quick, 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 quick. Quick, people, quick, quick. Majority wins here. Majority wins here. Majority wins here. Okay, people are saying bonding. Chalo, let's get bonding going. Where are you bonding? Where is bonding? Where is bonding? Here is bonding. Here is bonding. I know you love the bonding the most. And from chemical bonding, you know, like 3 to 4 questions you'll be expecting this year. Yeah? Okay. And bonding is easy. Yeah? Tell me the answer of this question. Which of the following is electron deficient? Which of the following is electron deficient? If you look at BCl3, only 6 electrons in its outermost shell. Electron deficient. Electron deficient. Now I want you guys to keep on letting me know the answers in the chats. Now it's your favorite, bonding. You do not have to use the pen paper here. Right? Look at the question and solve it. Look at the question and solve it. Which of the following is electron deficient? 2 minutes back, I told you BH3, right? And over here, they have given that B2H6 diborane. Perfect, it's electron deficient. In B2H6, you have got 3 centered 2 electron bonds. Yeah? Perfect. Done and dusted. Arrange the following on the base of the covalent character. Arrange the following on the base of the covalent character. Tell me the answer. Tell me the answer, people. Quick. Tell me the answer. Tell me the answer. More the charge on cation, more the polarizing power of cation, more the covalent character. Right? Increasing order, we have to say. Increasing order. So maximum covalent will be 4th. Right? This will be maximum covalent. Then, here it's going to be 3rd. Now, among these two, the charge on cation is same. Talk about the size. Lesser the size of cation, more the polarizing power of cation, more the covalent character. Here comes the 1. And here comes 2. Do you see any option like this? 2, 1, 3, 4. 2, 1, 3, 4. So, this is the increasing order. Yeah? This is the increasing order. This is the increasing order. The outer orbitals of carbon in ethene molecule can be considered to be hybridized to give 3 equivalent sp2 orbitals. The number of sigma bonds, okay, the number of sigma and pi bonds in ethene molecule. Quickly, ethene. Ethene, people. Both these carbons, they are sp2 hybridized. Both these carbons are sp2 hybridized. Now, how many sigma and how many pi? 1, 2, 3, 4, 5. 5 sigma and 1 pi. Nothing to check here. Okay? 5 sigma and 1 pi. Right, people? BF3 is planar and electron deficient. Hybridization and the number of electrons around the central atom will be BF3. Tell me, if I talk about your BF3, since it's forming 3 sigma bonds, It's sp2 hybridized. 2, 4, 6. 6 electrons in its valence shell. So sp2 and 6. Done and dusted. sp2 and 6. Tell me the answer of this question. You need to match it. Match the following. Quick. Match the following. Match the following. Match the following. Everyone. 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 Done? Match the following. Okay. If I start with PCl5, the type of the molecule is AB5L0. It has to be trigonal bipyramidal. Trigonal bipyramidal. So A with 4. There is only one okay, here it's also same. So I need not to check the second one because it's matched. Right? B with 3. Okay, let me check C. BRF5. The type of the molecule will be AB5L1. It's going to be square pyramidal. So C with 1. It has to be option A, which is the correct answer of the question. Right? Done? Moving ahead. Which of the following compounds is isostructural and isoelectronic? Isostructural and isoelectronic. Again, this sort of question we have solved many a times, if you remember. Again, this is the question which we have solved many a times, if you remember, people. So we have got, first of all, if I talk about IBR2 negative and XCF2. Check these. The type of this particular molecule. How do I check the type? Let me show it to you if you have forgotten how to check the type. Valence electrons in iodine will be 7. There is -1, so 7 plus 1 makes it 8. There are 2 surrounding atoms, so sigma is equal to 2. How many lone pairs? Out of 8, 2 have been used. Out of 8 valence electrons, 2 have been used to form 2 sigma bonds. So there will be 6 electrons left as such on iodine in the form of 3 lone pairs. The type of the molecule will be what? It will be AB2L3. AB2L3. This is the type of the molecule. AB2L3. If you talk about this one, xenon, its valence electrons are 8. Surrounding atoms are 2. That means sigma bonds are 2. Out of 8 valence electrons, 2 have been used. So there are 6 valence electrons left as such on xenon in the form of 3 lone pairs. So the type of the molecule is again AB2L3. If the type is same, that means these two are absolutely going to be isostructural. These are absolutely going to be isostructural. Correct, people? Which of the following pairs is isostructural, having same shape and hybridization? Can you check them out? Can you check them, people? Can you check them? Can you check them? If I see the options, I see one option, BF4 negative and NH4 positive. Let's calculate their hybridization and talk about all the things. Valence electrons in boron are 3. There is a negative charge, so 3 plus 1 makes it 4. Sigma bonds are 4. Lone pair is 0. Right? Steric number is 4 plus 0, 4. Hybridization is sp3. Type of the molecule is AB4L0. Right? Type of the molecule is AB4L0. Now look at the next one. Nitrogen. How many valence electrons? It should have 5, but there is positive charge, so 5 minus 1, 4. How many sigma bonds? 4 sigma bonds. How many lone pairs on nitrogen? 0. Steric number, 4 plus 0, 4. Hybridization, sp3. Type of the molecule, AB4L0. Right? Everything is same for these two. Correct? Everything is same for these two. I believe I'm clear. Tell me the answer of this question quickly. I am not solving this. You are going to solve this. I am not solving this. You are going to solve this. Quick. Quickly, guys, everyone. Quickly. We have to talk about hybridization, guys. This is NO3 negative, NO3 negative, and here we have got NO2 positive, and here we have got NH4 positive, right? Perfect, NH4 positive. We have to talk about the hybridization. It's pretty much simple. I don't know why you're taking a lot of time to solve this. See, nitrogen, how many valence electrons it has? 5. There is negative, so 5 plus 1 makes it 6. How many sigma bonds are there? There'll be 3 sigma bonds. How many lone pairs will be there on nitrogen? 0 lone pairs. Type of the molecule is AB3L0. Steric number is sigma plus lone pair 3. Hybridization will be sp2. Talk about this one. Valence electrons, 5 minus 1, that comes out to be 4. Sigma bonds will be 2. Lone pair on nitrogen will be 0. Steric number will be 2 plus 0, 2. Hybridization, sp. Type of the molecule, AB2L0. Correct? Talk about NH4. You already know it's sp3. NH4 is sp3, nothing else. So I believe it's done and dusted. Okay, moving on to the next question. The number of lone pair of electrons on the central iodine in case of I3 negative. Can you solve this? Central iodine they're asking. First of all, I3 negative. If you talk about I3 negative can be written as I2 negative. I2 negative. Right? I2 negative. If you talk about this central iodine, how many valence electrons it has? 7. Negative, which makes it 1. 7 plus 1 makes it 8. Sigma, 2. There are 2 sigma. Lone pairs. 8 minus 2 is 6. And those 6 electrons I'm keeping here. So 3 lone pairs. Perfect. So on the central iodine, there are 3 lone pairs. That's all. That's all what I have to check. How many lone pairs are there on central iodine? There are 3 lone pairs on the central iodine. Done and dusted. Okay. Dipole moment order. Dipole moment order, people. Dipole moment order. CH3 is donating. CH3 is donating. If it is donating, so it will carry delta positive, it will carry delta negative. Donating, delta positive, delta negative. Right? Delta positive, delta negative. Delta positive, delta negative. Delta positive, delta negative. Delta positive, delta negative. Right? Moment direction is from positive to negative. Here it's positive to negative. They'll cancel out. Net dipole moment here is 0. Perfect. Positive to negative. And this is negative here. This is positive to negative. Look, one is going downwards. One is going in this direction. So they are at an angle of 120. They are at an angle of 120. If you talk about this one, positive to negative. Positive to negative. Right? This is positive to negative. This is positive to negative. Angle here is 60. Right? Lesser the angle, more is the net dipole moment. So the net dipole moment in the third case is maximum, followed by second, followed by first, right? So this has to be the order. In the third one, the net dipole moment has to be the maximum, right? Again, a simple question this is. Again, a simple question this was. One more question that has been asked in the NEET examination from the same dipole moment concept. From the same dipole moment concept, quickly. Which of the following set of molecules will have 0 dipole moment? 0 dipole moment, people. Which of the following set of molecules will have 0 dipole moment? Remember, AB2L0 type, AB3L0, AB4L0, right? AB5L0, AB6L0, AB4L2, AB2L3. Whenever you see molecules of these types, their net dipole moment will be 0. Will be 0. Done and dusted. Which of the following molecule is polar? How do you check whether the molecule is polar or not? If the net dipole moment is non-zero, the molecule is supposed to be polar. If the net dipole moment is 0, the molecule is supposed to be non-polar. Right? This molecule has the type AB3L0. This molecule has the type AB4L2. This molecule has the type AB4L0. This molecule has the type AB4L1. So net dipole moment of these 3 is 0. Perfect. So they are non-polar. So there is only one left. That's option 1. Correct? Correct, people. Correct, correct, correct. Correct. bond order sequence. Bond order sequence. You should know it by now. In case of 14 electron species, bond order will be 3. 15 electron species, bond order will be 2.5. 16 electron species, bond order is 2. 17 electron species, bond order 1.5. 18 electron species, bond order 1. 13 electron species, bond order 2.5. 12 electron species, bond order 2. 11 electron species, 1.5. 10 electron species, bond order is 1. Right? Now, O2. O2 is 16 electron species. O2 is 16 electron species. O2 positive is 15 electron species. O2 positive is 15 electron species. O2 negative is 17 electron species. 17. O2 dinegative is 18 electron species. These are their respective bond orders which you have to arrange. Simple. Right? Arrange them on the basis of their bond orders. Right? Simple question this was again. Okay. Which one of these will have highest bond order? Calculate the total electrons. Right? NO. 8 plus 7 makes it 15. So it's a 15 electron species. Cn negative. 7, 6, 13, 13, 1, 14. 14 electron species. 7, 6, 14, 14, 1 minus 1, 13. 13 electron species. Right? And 7, 6. 7 and 6 is 13 electron species. 14 electron species, as I told you, has the bond order of 3. 15 electron species will have 2.5. 13 electron species also 2.5. Right? This also 2.5. Maximum bond order is for Cn negative. Again clear? Again clear, people? Okay, again clear. Which chapter do you want the next? Let's go ahead with equilibrium now. Let's go ahead with equilibrium now. Understand and see what kind of questions can be asked from equilibrium chapter. The first question which is on your screen. Now you have to use your pen and paper. Now equilibrium, there is no break. I'll just continue the session for like 1-2 more hours and we are done. Quickly, guys. See, if you look at the first question, this is the ask. Oh my God, this has been asked 4 times. Same question has been repeated 4 times. That is why I keep on telling you, PYQs are very important. They can be directly or indirectly asked. Someone is asking about the organic. Organic PYQs will be taken by HSP, sir. Okay, organic PYQs will be taken by HSP, sir. And guys, tomorrow at 11 a.m. be there, right? That is going to be NEET 2024 most predicted paper for chemistry, wherein we shall be discussing only 50 questions. Most expected 50 questions of chemistry. So be there on time. Be there on time tomorrow. Yeah? All right. All right, people. Look at this particular question. A vessel of 1 liter capacity. We have got a vessel which has got 1 liter capacity. Leave the question. Let me first of all write the reaction. This is your reaction, right? A vessel of 1 liter capacity containing 1 mole of SO3. So initially, as per the question, we are given with 1 mole of SO3. Perfect. This will be 0. This will be 0. It is mentioned in the reaction. After some time, equilibrium is established. Equilibrium is established. And when equilibrium is established, 0.6 moles of SO2 are formed. So number of moles of SO2 formed at equilibrium, they are equal to 0.6. What are we supposed to calculate? The value of equilibrium constant Kc. The value of equilibrium constant Kc. Now try to understand. Initially, I'm starting with 1 mole, right? Let me make it as 1 minus 2x. Or you can start with 1 minus x as well. The choice is all yours. 1 minus 2x. Now see, 2 moles gives 2 mole, 1 mole gives 1 mole, so 2x gives 2x, right? 2 moles gives 1 moles, 1 mole gives 1 by 2, so 2x gives x. Correct? I got the moles of all the reactants products at equilibrium. I got the moles of all reactants products at equilibrium. Now, as per the question, moles of SO2 at equilibrium, which came out to be 2x, that 2x is equal to 0.6, so the x value is nothing but 0.3. Correct? 0.3. So 1 minus 2x, 2x is 0.6. So 1 minus 0.6 is 0.4. 2x is 0.6 here, x is 0.3. I got the moles of reactants products at equilibrium, right? Since the volume of the vessel is 1 liter, so divide everyone with 1 liter. I got the concentration of each reactant product at equilibrium. I got the concentration of each reactant product at equilibrium. Now, my dear students, if I want to write the Kc expression, I can do that. Concentration of SO2 at equilibrium, that is 0.6 raised per stoichiometric coefficient 2. Concentration of O2 at equilibrium raised per stoichiometric coefficient 1. Concentration of SO3 at equilibrium. Concentration of SO3 at equilibrium raised per stoichiometric coefficient, that's 2. Solve it and get the value of Kc. Done and dusted. This sort of equation has been frequently asked in NEET. It has been frequently people asked in NEET. Frequently means frequently. Okay, one more question. It is the asked question again. Given that the reaction between two gases represented by A2 and B2 to give the compound, at equilibrium, the concentrations are given. If the reaction takes place in a sealed vessel at this temperature, the value of Kc will be. Again, one basic question. All the things are given. All the things are given. You just need to write the Kc expression for this particular reaction, which you will start from the products. It is concentration of AB at equilibrium raised by stoichiometric coefficient divided by concentration of A2 at equilibrium raised by stoichiometric coefficient, concentration of B2 at equilibrium raised by stoichiometric coefficient. All these terms are given to us. What is the concentration of AB at equilibrium? It is 2.8 into 10 raised by minus 3 whole raised by 2 divided by concentration of A2 at equilibrium is nothing but 3 into 10 raised by minus 3. Concentration of B2 at equilibrium is also given to me. That is 4.2 into 10 raised by minus 3. It is just the matter of calculation, no concepts involved, and you are done. Right? Right, people? Right, people? Perfectly done. I'm moving on to one more question. Tell me the answer of this question. Again, this is the repeated question. It has been asked 2 times. It has been asked 2 times. The equilibrium constant of the reaction is 300, right? If the volume of the reaction vessel is tripled, the equilibrium constant will be. Equilibrium constant, does it depend on volume? I'm asking this question to you. Equilibrium constant, does it depend on volume? I'm hearing it for the first time. It does not depend on volume. It will remain the same. Right? It will remain the same. It will remain the same. One simple and basic question. Again, it is asked question. I would want you all to kill this one. The rate constant for forward and the backward reactions are given. The rate constant for forward and backward reactions are given. 1.1 into 10 raised per minus 2, 1.5 into 10 raised per minus 3, right? Per minute respectively. Equilibrium constant for the reaction. We are supposed to calculate equilibrium constant for this reaction. You know, what is Keq basically? How do you define equilibrium constant? Equilibrium constant is nothing. It is the rate constant of forward to that of rate constant of backward, right? That's how you define equilibrium constant. Kf value as per the equation is given to us. Divided by Kb is also given to us. Solve it and kill it, right? Done? Again, simple. I am moving on. I am moving on. I am moving on. All right. Again, one question which has been asked. Look at the question carefully. Given that equilibrium constant of the reaction has the value of 278 at a particular temperature, okay, what is the value of equilibrium constant for the following reaction? All right. Look at the first reaction, my dear students, that's given to us. Okay, look at the first reaction. What I'll be doing, first of all, if I reverse this reaction, it becomes 2 times SO3 in equilibrium with 2 times SO2 plus O2. Since you have reversed the reaction, so its equilibrium constant now would be inversed. So it's 1 upon 278. Correct? Now, if I multiply this reaction with 1 by 2, this becomes SO3, this becomes SO2, this becomes half of O2. Since I have multiplied this reaction by 1 by 2, that 1 by 2 goes to the power of equilibrium constant, right? So this is 1 by 78 raised power 1 by 2. Look at this particular reaction and look at the given reaction. Are these 2 reactions same? Yes, these 2 reactions are same, right? Now get it solved and you are done getting the equilibrium constant. Yeah? Perfect. Perfect, people. I hope this is clear. I hope this is clear to everyone. Correct? Right, guys? Is it clear? Is it clear? Is it clear? Surely, I'll be coming up with one more session in which I shall be discussing all the graphs of chemistry. Okay? Answer of this question will be 6 into 10 raised per minus 2. Same, again, one question which has been asked 2 times. One question which has been asked 2 times. The question is, in which of the following Kp is greater than Kc? You know your Kp is equal to Kc RT raised per delta Ng. This is your reaction, right? Perfect. What do we have to check? In which of the following Kp is greater than Kc? I'll say Kp will be only greater than Kc here if delta Ng will be greater than 0. Now, for which reaction delta Ng is greater than 0? Check it out. If you look at the which reaction? Okay. If you look at this particular reaction, right? Delta Ng for this reaction is equal to number of moles of gaseous products, which is 1 plus 2, which makes it 3, minus 2, that comes out to be 1. So delta Ng is greater than 0. So this is the reaction in which Kp will be greater than Kc. Yeah? Simple? Simple, people? Tell me the answer of this particular question quickly. Again, the asked question. Again, the asked question. Again, the asked question. Everybody. Again, the asked question. Everybody. Check it out quickly, guys. Done? Done? You know Kp is equal to Kc RT raised by delta Ng, right? So Kp divided by Kc will be equal to RT raised by delta Ng. So calculate delta Ng, people. Delta Ng is equal to number of moles of gaseous products, which is 1, minus number of moles of gaseous reactant, which is 1 plus 1 by 2, which makes it 3 by 2. So 1 minus 3 by 2 is minus 1 by 2. Correct? So Kp by Kc is equal to RT raised by minus 1 by 2, which will be 1 divided by under root of RT. 1 divided by under root of RT. So it's option C, which is the correct answer of the question. Right? One more similar type of question that has been asked. You need to check it out. You need to check it out. You're given with the reaction Kp is equal to Kc RT raised by X. Right? What do we have to calculate? X. So Kp is equal to Kc RT raised by delta Ng. So X is nothing but delta Ng. So get delta Ng for the reaction. Number of moles of gaseous product, which is 1, minus number of moles of gaseous reactant, which is 1 plus 1 by 2, makes it 3 by 2. The value comes out to be minus 1 by 2. X is minus 1 by 2. Correctly done? Yes, it's done. In which of the following Kp and Kc are not equal? You know, Kp won't be equal to Kc when delta Ng is non-zero. Now, select that particular reaction where delta Ng is non-zero. Select that particular reaction where delta Ng is non-zero. First reaction. Moles of gaseous products 2. 2 minus 1 is 1. Delta Ng is non-zero. Here Kp and Kc won't be equal. Right? Here Kp and Kc won't be equal. So A only. Right, people? Alright. Let's have a look on one more question. Let's see what the question says. If alpha is the fraction of Hi dissociated at equilibrium in the reaction this, starting with 2 moles of Hi, the total number of moles of reactants and products at equilibrium. Again, simple question. See, this is 2 times Hi, 2 times Hi gas. It's in equilibrium with H2 gas plus what? Plus I2 gas. As per the question, we are starting with 2 moles of HI, right? We are starting with 2 moles of HI. This will be 0, this will be 0. If the degree of dissociation is alpha, so at equilibrium, this has to be 2 minus 2 alpha, right? 2 minus 2 alpha. I can write it like this. Perfect. A minus A alpha, correct? So 2 gives 1, 1 gives 1 by 2, 2 alpha gives alpha. 2 gives 1, 1 gives 1 by 2, 2 alpha gives alpha. So total moles at equilibrium. Total moles of reactants products at equilibrium. Total moles of reactants products at equilibrium has to be equal to 2 minus 2 alpha plus alpha plus alpha. The value comes out to be 2. Done? The value comes out to be 2. I hope this is also clear. Alright, let's have a look on this particular question. What the question says, let's see. The equilibrium constant for the reaction is given if the initial concentration of all the 4 species was 1 molar each. The equilibrium concentration of D. Guys, this question has been asked many a times in different examination. I'm telling you, same question with same values, everything same. Everything same. Okay, let's try to solve this. As per the question, the reaction is A plus B. It's in equilibrium with C and D. Initially, you're starting with 1 molar concentration of each. Now, at equilibrium, if I ask you what is the concentration of A, it has to be 1 minus X. This should be also 1 minus X. This will be 1 plus X. This will be 1 plus X. These are the concentrations of all the reactants products at equilibrium. You should know it now. Okay. Now, if I write the Kc expression, it is concentration of C multiplied by concentration of D divided by concentration of A, concentration of B. It comes out to be 1 plus X divided by 1 minus X ka whole square, right? And Kc is nothing but 100. So 1 plus X divided by 1 minus X came out to be 10. So 1 plus X is equal 10 minus 10X. So I can say 11X is equal to 9, which tells you that X is equal to 9 by 11. X is equal to 9 by 11. What am I supposed to calculate? Look at the question. I'm supposed to calculate the concentration of D at equilibrium. And as you can see, concentration of D at equilibrium is 1 plus X. So 1 plus 9 by 11, the value comes out to be 20 by 11, which comes out to be 1.8 molar. So this is the concentration of D at equilibrium. I believe you can solve this sort of question from now onwards. Yeah? This sort of equation you'll frequently find, people. Frequently you'll find this sort of equation. Okay, one more similar sort. One more similar sort of question. I'm given the reaction. The reaction is A plus B. It's in equilibrium with C and D. This is the reaction. If initially the concentration of A and B are both equal, okay, concentration of A and B are both equal. Let the concentration be A. Let the concentration be A. But at equilibrium, concentration of B is twice that of A. What will be the equilibrium constant? Okay. So at equilibrium, the concentration of this A will be, this will be A minus X. This will be also A minus X. This will be X and this will be X. So I got the concentrations of each reactants products at equilibrium. So Kc expression has to be equal. Okay, wait. One thing which is given in the question. One thing which is given in the question. At equilibrium concentration of D. At equilibrium the concentration of D, that is X. At equilibrium the concentration of D will be twice that of A. Twice that of A. Twice that of A. Correct? Okay, so from here what can I conclude? X is equal to 2A minus 2X, or I'll say 3X is equal to 2A, or I'll say X is equal to 2 by 3A. X is equal to 2 by 3A. I got the X here first. I got the value of X here. If you got the value of X, you can write the expression for Kc now. Kc is concentration of C, concentration of D, which comes out to be X square, divided by concentration of A, concentration of B, which is A minus X square. A minus X square, right? A minus X square. So Kc you can write as X square, right, as such, divided by, you know, A minus X. A minus X is nothing but X by 2. So this is X by 2 ka square. So X square cancel. The value finally comes out to be 4. So option 4 is the one which is correct. This sort of equation can be again asked, people, right? Have an eye on these sort of questions as well. Okay? Look at this one. I think this sort of equation, guys, many a times we have solved, right? Many a times we have solved this sort of equation. Many a times. I hope you remember. In my regular marathons, I've solved the same question again and again. Yeah? So this question I'm not solving. So you'll be starting with the pressure basically. Perfect? You'll start with the pressure. 800, then 800 minus x, and accordingly. Yeah? I believe all my regular students, they would be knowing. Okay, one more question. The last one. At equilibrium, the observed molecular mass of N2O4 is this, right? The observed molecular mass of N2O4 is this. The percentage dissociation of N2O4. Can you solve this? Vapor density measurement. Vapor density measurement, guys. Alpha is equal to capital D minus small d divided by small d multiplied by n minus 1. Right? Perfect. This is the result which you'll be using. And when you solve the question, or my dear students, you can use this result directly as well. This result can be directly used as well. Theoretical molar mass of the reactant, which will be approximately 92, minus observed molar mass divided by observed molar mass. This result you can use directly as well. There is no worry at all. You can remember it. You can remember it directly. Theoretical molar mass of the reactant. Molar mass of reactant is N2O4 minus observed one is, that's given in the equation, 80. Perfect? Right? You can remember it directly. You can remember it directly. Okay, one question based on Le-Chatelier's principle. Can you check it out? Can you check it out? For the reversible reaction, the equilibrium shifts in forward direction. The equilibrium shifts in forward direction by increasing the concentration of NH3. If you increase the concentration of NH3, equilibrium will try to decrease it, so backward. So here, this cannot be. By decreasing the pressure. If you decrease the pressure, equilibrium will try to increase it. So backward again, this cannot be. By decreasing the concentration of N2, if you decrease the concentration of N2, equilibrium will try to increase it. So backward again. But we have to check the forward, right? So option 4 has to be the one. Option 4 has to be the one. Yeah? Absolutely. Moving on to the next one. Moving on to the next one. Look at this question, guys. What the question says? Let's have a look. In equilibrium condition, pressure of O2 is dependent on. Pressure of O2 is dependent on. Pressure of O2 is dependent on. Pressure of O2 depends on the amount of O2 at equilibrium. See, this is solid. This is in solid form. It has got nothing to do with anything at equilibrium. Nothing to do with anything at equilibrium because their active mass is unity, right? So the pressure of O2 will be affected due to the amount of O2. More the amount of O2 formed, more the pressure of O2, right? Now, in equilibrium condition, the pressure is dependent on what? Is dependent on what? Is it dependent on mass of BaO2? No, its active mass is unity. It has got nothing to do with solid. This also. So it's going to be temperature. So temperature is going to see with by changing the temperature, the amount of O2 will change. And when amount of O2 changes, the pressure of O2 automatically changes. Yeah? Right? Tell me the answer of this question. Again, it's an asked one. Again, it is the asked question, people. Again, it is the asked question. At the given temperature, equilibrium amount of carbon dioxide. How can you increase? How can you increase the amount of carbon dioxide? If you decrease the amount, if you increase the amount of CO, equilibrium will try to decrease it. How equilibrium will decrease the amount of CO? When it shifts the reaction forward. So by increasing the amount of CO, right? Perfect. All right. Look at this particular question. The pH of 0.01 molar NaOH, right? So I'll say OH negative concentration here is nothing but 10 raised power minus 2 molar. If OH negative concentration is 10 raised power minus 2 molar, POH will be 2. If POH, what is POH first of all? It is minus log of OH negative concentration. So it is minus log of 10 raised power minus 2. The value comes out to be 2. So if POH is 2, then you should know pH plus POH is nothing but 14. Therefore, pH is equal to 14 minus POH. The value comes out to be 12, right? Done? Simple. I can see majority has already solved this. That's great. Okay, moving on to one more. The question has been asked in NEET 2009. NEET 2009 question this is. NEET 2009 question this is. Ionization constant of ammonium hydroxide. Ammonium hydroxide. It's a weak base. Its ionization constant Kb has been given as this much. Hydrolysis constant of ammonium chloride. Hydrolysis constant of ammonium chloride is. Hydrolysis constant of ammonium chloride is. Tell me one thing. This NH4 positive, this is Cl negative. Can I say this NH4 positive would have come from NH4OH? This Cl negative would have come from HCl. This is a weak base. This is a strong acid. So I would say this is the salt of weak base and strong acid. And whenever the salt of weak base and strong acid undergoes hydrolysis, how do we calculate its hydrolysis constant? It will be equal to Kw divided by Kb. Kw at 25 degrees centigrade is 10 raised per minus 14. And Kb is given as 1.77 into 10 raised per minus 5. Matter of calculation and get it done. Right? Simple formula based. Just identify the salt, apply the formula, you're done. I hope I'm clear. Okay. NEET 2007. Calculate the pOH of the solution that contains this much hydronium ion concentration. Concentration of H3O positive, which I can write as concentration of H positive, is 10 raised per minus 10 molar. Therefore, pH will be equal to minus log of H positive concentration. So it has to be minus log of 10 raised per minus 10. The value comes out to be 10. So pH is 10. If pH is 10, then pOH, you know your pH plus pOH, that is equal to 14. That is equal to 14. So pH is equal to 14 minus pOH. So 14 minus 10 comes out to be 4. Perfect. So pH is equal to 4. Correct, guys? Done? Okay, one more question in 2006. Take the question, try to solve this. Take the question, try to solve this. Hydrogen ion concentration. Hydrogen ion concentration, H positive concentration is given to me as how much? 10 raised per, wait. Okay, I have to calculate hydrogen ion concentration. Got it. Check it out. Understand, guys, what this question is all about. As per the question, you have taken HCl, you are putting it into water, right? This HCl would have got dissociated as H positive aqueous plus Cl negative aqueous. Correct? You're introducing HCl into water. Now, as per the question, initially you are taking 10 raised per minus 8 molar of this. This will be 0, this will be 0. Now it's a strong acid, so this is 0. This will be 10 raised per minus 8 molar. This is also 10 raised per minus 8 molar. So what is the concentration of H positive coming from HCl? Concentration of H positive coming from HCl is 10 raised per minus 8 molar. Right? This is the concentration of H positive coming from HCl. But what we did initially, we took HCl, we introduced HCl into water. You know already water is a weak electrolyte, right? So in water there were already H positives. How many H positives were there in water? It was 10 raised per minus 7 molar at 25 degrees centigrade. If I ask you what is the net H positive ion concentration, that will be this plus this. If I take 10 raised per minus 8 as common, it will be 1 plus 10, which comes out to be 11. So 11 into 10 raised per minus 8 molar is the net H positive ion concentration. Correct, guys? These sort of questions we have discussed in detail in the marathons. I believe you know them already. Okay, look at this one. Look at this one, guys. Look at this one. What is the H positive ion concentration of the solution prepared by dissolving 4 grams of NaOH? So how many moles of NaOH do we have? Given mass of NaOH divided by molar mass of NaOH. 1 by 10, 10 raised per minus 1. So these many moles of NaOH. Perfect. These many moles of NaOH. What is the volume of the solution? 1000 ml. That means 1 liter. So if I ask you what is the concentration of NaOH? Concentration of NaOH means moles of NaOH divided by volume in liter. It comes out to be 10 raised per minus 1 molar. So can I say Concentration of OH negative is nothing but 10 raised power minus 1 molar. What do I have to calculate? If this is H positive, if this is OH negative concentration, you know, concentration of H positive multiplied by concentration of OH negative at 25 degrees centigrade is 10 raised power minus 14. 10 raised power minus 14. So concentration of H positive is equal to 10 raised power minus 14 divided by concentration of OH negative. So this is 10 raised power minus 14 divided by 10 raised power minus 1. The value comes out to be 10 raised power minus 13 molar. Right? Simple? Simple, people? I hope I'm clear. I hope I am clear. Right? Right, people? Okay, tell me the answer of this question. 1995. 1995. 1995. The pH value of 10 molar solution of HCl. 10 molar solution. So concentration of H positive here is 10 molar. It's given to me. So what will be pH? Minus log of H positive concentration. It comes out to be minus 1. So pH has to be less than 0. pH has to be less than 0, right? pH has to be less than 0. Correct? Okay, 2020 the question has been asked. In 2020 the question has been asked. Find out the solubility of NiOH whole twice. NiOH whole twice, right? NiOH whole twice. In what? In NaOH. In NaOH. Given that ionic product of this is 2 into 10 raised power minus 15. Okay. So how it would have undergone dissociation? Ni di positive plus 2 times OH negative, right? And this would have got completely dissociated as Na positive plus OH negative. So over here, if you look carefully, let the solubility of this is S. So this will be S, this will be 2 times S. Concentration of NaOH was 0.1 molar. So initially this would be 0, this 0. This will be 0.1, 0.1, 0.1. Now, in the same container, we have got weak electrolyte, strong electrolyte, right? And both are having one ion in common, that is OH negative. So what is the net OH negative concentration? It will be 2S plus 0.1, which will be approximately taken as 0.1 only. Perfect. Now, if you remove this part, I'll be writing the ionic product expression for this particular species, which will be concentration of Ni di positive raised power 1, concentration of OH negative raised power 2. What is the ionic product value? That is 2 into 10 raised power minus 15 is equal. Na positive, that is S. OH negative is how much? 0.1 raised power 2. So I would say S is equal to 2 into 10 raised power minus 13 molar. Is there anything like that? Yes, it's option 4. Right, people? It's simple. We have done these sort of questions in detail, if you remember. I've told you the approach of solving these questions with the help of common ion effect. With the help of common ion effect. One more similar question. This will be also done in the similar way with the help of common ion effect. Right? I am not solving this one. I am not solving this one. Can you give it a try? Can you give this one a try? You have got the saturated solution of CaOH whole twice. It is pH is equal to 9. If it is pH is 9, that means its pOH will be equal to 9.5. Then only it comes out to be 14. Right? pOH is 14. If pOH is 14, what does that mean? That means OH negative concentration is 10 raised power minus 5 molar. Now, CaOH whole twice. How it undergoes dissociation? It will be calcium di positive plus 2 times OH negative. Right? If it is solubility is S, this will be S, this will be 2 times S. Write the expression for KSP. Or wait, before writing the expression for KSP, I already know the OH negative concentration. Correct? I already know the OH negative concentration. OH negative concentration is 10 raised power minus 5 molar. But you know OH negative concentration is 2 times S. So 2 times S is 10 raised power minus 5. S is 10 raised power minus 5 divided by 2 molar. Perfect. Now I can write the KSP expression. KSP expression will be concentration of calcium dye positive raised power stoichiometric coefficient, concentration of OH negative raised power stoichiometric coefficient. Concentration of calcium dye positive is what? S, and S value is 10 raised power minus 5 divided by 2. Concentration of OH negative, that is 10 raised power minus 5. So 10 raised power minus 5 raised power 2. So this will be 10 raised power minus 10, 10 raised power minus 15. So 10 raised power minus 15 divided by 2 is the value of KSP. Correct? So it will be 0.5 into 10 raised power minus 15. So option 1 is the one which is correct. Option A is the one which is correct among all. You can solve this question in this way, which was again simple only. Right? So we have got the similar sort of questions. Tell me the answer of this particular simple question which we have here. Okay, simple question which we have here. Ostwald's dilution law is applicable only to? Ostwald's dilution law is applicable only to what? You should know it. Ostwald's dilution law, you should know it. It's applicable to what? It is applicable to? Absolutely. It's applicable to weak electrolytes, right? And as per Ostwald's dilution law, what happens? What happens? Degree of ionization of the weak electrolyte, that increases upon dilution. Tell me the answer of this question. Tell me the answer of this question. Tell me the answer of this question. The pH of the aqueous solution of ammonium formate. Ammonium formate, right? Ammonium formate is the salt of weak acid and weak base. Ammonium formate is the salt of weak acid and weak base. Now, how do you calculate the pH? How do you calculate the pH? There is a formula, I hope you know. 7 plus half of, this is pKa minus pKb. Correct? So it's 7 plus half of. What is pKa? pKa is 3.8. What is pKb? Minus what is pKb? That is minus 4.8. Perfect. Matter of calculation. Solve it. Get the pH. So these were all your questions in equilibrium. Perfect. Bonding, we have solved. Let's move on to electrochemistry. Let's move on to electrochemistry. Let's move on to electrochemistry, people. Let's move on to electrochemistry. The first question in electrochemistry, the question asked in NEET 2019. NEET 2019. Guys, I'll just take half an hour more. That's all. I'll just take half an hour more. After that, you can have your dinner, etc. The standard electrode potentials, Al tri positive gives Al plus 3 to 0. Decrease in oxidation state means reduction. Basically, SRP values are given. SRP values are given. Right? SRP values. These are SRP values. The correct decreasing order of the reducing power. Reducing power. Let me tell you, reducing power. You know, better reducing agent has more reducing power. Better reducing agent has more reducing power. Right? Now, reducing agent undergoes oxidation. So the one which undergoes oxidation quickly, is the better reducing agent. Now, which one undergoes oxidation quickly? The one which will be having more SOP. More SOP, more the tendency to undergo oxidation, better reducing agent, more reducing power. Right? Now, these are all SRP values given. These are all SRP values given. If I convert them into SOP values, this becomes plus, this becomes minus, this becomes plus, this becomes plus. Now, where do you see maximum SOP value? Which one is maximum SOP value here? Plus 2.93. Plus 2.93 is the SOP for what? It is the SOP for silver. So silver has got maximum reducing power. Silver has got maximum reducing power. So it is option A, which is going to be the correct answer among all. Right? Is it for silver or potassium? Just a second. This for potassium, sorry. This is for potassium. Potassium. Okay. Which one is the minimum SOP value? Minimum SOP value is which one? Minimum SOP value is this one. And it's for what? It's for silver. So silver will have least. So it has to be option B. Yes, you all are perfectly right. It has to be option B. It has to be option B. It has to be option B. Okay. Tell me the answer of this particular question. The question has been asked in AI PMT 2012. Standard reduction potentials are given. The strongest oxidizing and reducing agents. If I talk about the oxidizing agent itself undergoes reduction, right? Perfect. The one which has got more SRP will undergo reduction quickly, will be the better oxidizing agent, right? The one which has got more SRP will undergo reduction easily, will be the better oxidizing agent. Now, which one has got maximum SRP? Maximum SRP, as I can see, as I can look the values, there's the maximum SRP here. Maximum SRP is for F2. So F2 is definitely the better oxidizing agent. F2 is definitely the better oxidizing agent, right? Or let me check it again, guys. Oxidizing agent undergoes reduction, right? So more SRP, more tendency to undergo reduction, better oxidizing agent. Yes. F2 will be the strongest oxidizing agent. Yes. F2 will be the strongest oxidizing agent. F2 will be the strongest oxidizing agent. It has to be A only. It has to be A only. Okay, it has to be A only. Understand this particular question. Look at the question carefully and see how you are going to solve this. So first of all, Sn plus 4 to Sn plus 2. Decrease in the oxidation state means reduction. So this is the SRP value. This SRP. Plus 3 to 0. Again SRP. Okay, again SRP. So when these two electrodes are connected to make a cell, the cell potential is. Now among these two electrodes, which one has got more SRP? This is more SRP. More SRP means more tendency to undergo reduction, right? And reduction takes place at cathode. So this is your cathode here. This is your cathode here. And this automatically becomes your anode. Perfect. How do we calculate E naught cell? You should know it. E naught cell is nothing. It is E naught cathode minus E naught anode. What is E naught cathode? This is SRP of cathode. This is SRP of anode. What is the SRP of cathode? SRP of cathode is 0.15. What is the SRP of anode? That is minus 0.74. The value comes out to be 0.89 volts. Correct? So it has to be option B. E naught cell I was supposed to calculate, nothing else. Okay, E naught cell I was supposed to calculate, nothing else. Look at this particular question. This particular question again has been asked in 2 examinations. Okay, 2 reactions are given. This is the oxidation reaction, So these are the SOPs. EMF of the cell. See, zinc is undergoing oxidation here. Zinc is undergoing oxidation. So this oxidation is at anode. So this automatically becomes cathode. What do I need to calculate? I need to calculate E naught cell, which is equal to, E naught cell is equal to E naught cathode minus E naught anode, which will be equal to SRP of cathode. What is SRP of iron? What is SRP of iron? This is SOP. I need SRP. So minus 0.44 minus SRP of anode. SRP of anode. This is SOP of anode. I need SRP of anode. Correct? So this value will be how much? How much it comes out to be? Plus 0.32 volts. So plus 0.32 volts is going to be the answer of the question. This question, if you look at this question, the question has been asked in AIMS 2019. Calculate the EMF of the cell if E naught is given. Calculate the EMF of the cell if E naught value is given. All right. So first thing, people. First of all, I'll be writing the reaction taking place at anode. And you can see over here, M gives M di positive. I would say M solid gives M di positive aqueous, whose concentration is 0.01 molar plus 2 electrons. This is the reaction at anode. Now, similarly, if I ask you what is going to be the reaction at cathode, I would say at cathode, what happens? Reduction takes place. M di positive gives M. So the reaction has to be M di positive, whose concentration is 0.001. It will be gaining 2 electrons. It will be getting converted into M solid. Since electrons are balanced, so I can directly add these two reactions. So this term cancel, two electron cancel. So it's M di positive, whose concentration is 10 raised power minus 4 molar. It gives M di positive, whose concentration is 10 raised power minus 2 molar. If I talk about the QC value, it will be 10 raised power minus 2 divided by 10 raised power minus 4. The value comes out to be 10 raised power 2. So this is QC. I got QC. I got the N value as well. N value here is 2. E naught is already given to me. Now it is the time to use your Nernst equation. Nernst equation says that E cell is equal to E naught cell minus 0.0591, which I will take as 0.06 divided by N log of QC. QC is 10 raised power 2. So it is 4 minus 0.03 multiplied by log of 10 raised power 2 is 2. So 4 minus 0.06, which will be how much? Which will be 5.94. So 5.94 volts, 3.94. 3.94 volts is going to be the correct answer of this particular question. It's option A. Simple. Just use the Nernst equation and solve the question. That's all. That's all. Similar sort of question which has been asked in 2003. Similar sort of question which has been asked in 2003. Reaction is given, E naught is given. N value is 2 as far as the reaction is concerned. QC will be equal to 1 divided by 0.1. 1 divided by 0.1, the value comes out to be 10. Now, your E cell is equal to E naught cell minus 0.0591 divided by N log of QC. Log 10 is 1. So, it is just the matter of calculation, right? Solve this value, get the answer in volts. That's all. Correct? That's all. That's all, people. This question has been asked in NEET 2019. NEET 2019. For the cell reaction involving one electron, E naught cell is given. E naught cell is given. Now, the equilibrium constant. I need to calculate equilibrium constant. So, in order to calculate equilibrium constant, I'll make sure the cell reaches equilibrium stage. And at equilibrium, you should be knowing E cell is equal to 0. At equilibrium, your E cell is 0. So, again, I'll be using Nernst equation only. I can say E naught cell is equal to 0.0591 divided by N is 1. This is log of KEQ. Log of KEQ. E naught cell is 0.59 divided by 0.0591 is equal to what? Log of KEQ. Log of KEQ. Correct? This is 1, this is 10. So log of KEQ comes out to be 10. It is to the base 10. So from here you can say KEQ is equal to 10 raised power 10. So 10 raised power 10 is the answer of the question. So option C is the one. So all these questions, I believe, my dear students, you can easily solve. You can easily solve for sure. Okay, one more. The standard Gibbs free energy we have to calculate. Okay, delta G naught we have to calculate. Delta G naught is equal to, minus NF E naught. Minus NF E naught. I think all the things are given. What are we supposed to calculate? Nothing. Delta G naught is equal to minus N value for this reaction, as you can see, that's 2. Faraday's constant is 96500. E naught cell is 2 volt. But since I have taken E naught cell in volts, I have taken all these parameters as per SI system. So delta G naught will come in joules as per SI system as well. But I have to calculate answer in kilojoules. So I'll be dividing it with 1000. Now the answer is going to be in kilojoules. Now again, it's a matter of calculation only, nothing else. Again, it's a matter of calculation only, nothing else. All these questions can be solved easily, guys. Just provided you know the concept, nothing else. A solution of NiNO3 is electrolyzed between platinum electrodes using 0.1 farad electricity. How many moles of nickel will be getting deposited? So first of all, nickel will be getting deposited cathode. And for the nickel to get deposited, the reaction has to be Ni di positive plus 2 electrons gives nickel solid. Then only this nickel solid will get deposited. If I ask you first of all, what is the N factor of nickel? It is moles of electrons exchanged divided by stoichiometry coefficient, which comes out to be 2, right? Now, moles of nickel deposited is equal to I multiplied by T, I can write as Q. N factor of nickel multiplied by 96500. How much charge? We are passing 0.1 farad. So 0.1 multiplied by 96500 divided by N factor here is 2. multiplied by 96500. So this term cancel. The value comes out to be 0.05. So 0.05 moles of nickel have been deposited. Right? This formula I've taught you many a times in the electrochemistry. The number of moles of substance deposited or liberated. Okay? Similarly, you've got one more question. The number of farads required to produce 20 grams of calcium. 20 grams of calcium. So first of all, for the calcium to get deposited, the reaction has to be calcium di positive plus 2 electrons. It gives calcium solid. What is the N factor of calcium solid here? It is 2. Perfect. The number of farads required to produce 20 grams. So first of all, mass of calcium deposited will be equal to equivalent mass of calcium multiplied by I into T, which is Q, divided by 96500. What is the mass of calcium deposited? That's 20. Equivalent mass of calcium is molar mass of calcium divided by N factor. Here in the denominator, it's 96500, and this is Q over here, right? So this is 40, 40, 40 cancelled. So Q comes out to be 96500 coulombs, which is nothing but 1 farad. Correct? Simple. Again, it's a simple question. You can solve this. You can solve this easily. Okay. Look at this one, NEET 2016. NEET 2016. The molar conductivity of a solution of AgNO3 with this molar conductivity, lambda m. Lambda m is equal to kappa multiplied by 1000 divided by molarity, when it has to be calculated in Simon centimeter square per mole. Perfect. Lambda m we need to calculate. What is conductivity? What is conductivity? How much is it? 5.76 into 10 raised power minus 3 multiplied by 1000 divided by. Molarity is how much? It is moles per liter basically. So 0.5. So this term cancel. Solve it. Get the answer. Yeah? Get the answer. It will be 11 point something, I believe. This is going to be the answer. Option B. Option B is going to be the one which is going to be the answer of this question. All right, we have got one more. AIMS 2018. AIMS 2018. 0.1 molar solution is present in the conductivity cell with the electrode of area placed 1 centimeter apart. Resistance is this. What is the molar conductivity? So lambda m we have to calculate. Lambda m, you know, that is kappa multiplied by 1000 divided by molarity. Now molarity is given. Kappa we are not given with. So kappa is nothing but 1 by R multiplied by L by A, right? So kappa has to be equal. Conductivity has to be equal to 1 divided by R. What is R? R is 5 into 10 raised power 3. What is L? Distance between the electrodes, area of cross section, 100 centimeters square. So from here you can calculate kappa, right? You can calculate conductivity. Once you get conductivity you got, molarity is given, put it in this expression and get the value of lambda m. Again, one simple and basic question I would call this as. I would call this as again one and simple and basic question. Okay? Perfect. Perfect. Guys, I need to stop the session. My throat is paining. Is everything clear till here? HSP sir is going to come up with the inorganic, with the organic PYQs as well. Well, I'm left with 2-3 more chapters, right? I'll do that tomorrow. But tomorrow there is one session, guys. Tomorrow there is one session which is scheduled in the morning at 11 a.m. Tomorrow at 11 a.m. there is one session scheduled at 11 a.m. The session is already public. Check that out. That is most predicted chemistry paper, right? I shall be solving 50 questions with you. But trust me, majority of the questions directly and indirectly out of my experience will be asked for sure. That's a combined session. That's a combined session. Me and HSP sir will be taking that combinedly. So do not miss that at any cost. Tomorrow at 11 a.m. Ashwin, I have spoken to Yavar sir. Let me see what he says. He'll be doing that. He'll be doing that. Okay? Do let me know in the comment section how you liked this particular session. Exactly. Last year, many questions came from predicted paper. That's why I'm telling you. Do watch that tomorrow. I'll see you tomorrow exactly at 11. Huh? Okay? I hope whatever I discussed, you got the idea of what all things are asked. I hope you got the idea. Perfect, guys. Chalo. Take care. God bless you all. Bye-bye.